Now, dear student, chapter number 10 Mechanical Properties of Fluids. And today we have the topics for the discussions are here: equation of continuity and energy of a fluid in a steady flow. So, whenever we are just discussing a fluid dynamics, so here we have the one of the bigger topic that is called the Bernoulli principle. So, this principle is based on the concept of the equation of the continuity, and always these content talk about a ideal condition. That mean always they are just making the flow of a liquid in a steady manner, that is called the streamlined flow. So here we are just starting the equation of continuity, and to discuss the equation of continuity, here I am just making a assumptions of a flow of non-viscous incompressible liquid through a tube which having the varying cross section. And here I am just assuming the two sections of a that mean tube. One is the quite broader is there, and one part is that is quite narrower is there. Okay, through which we are just assuming the mass of the liquid that flowing in a small interval of time, or whatever the time interval we have. So same quantity which entering inside a tube is equal to the same quantity which is that mean leaving the tube is there. So definitely the equation of continuity is based upon the concept of the conservation of mass. So already in the physics we have discussed the conservations of the following things. That mean conservation of charge is there, conservation of the momentum is there, conservation of the angular momentum is there. And so we have the another the thought process of the conservation of mass is there, that is having the name equation of continuity. So how can we dictate it? So here we are just finding the amount of a liquid at section A which passing in a delta t time. So here we are just making the simplest assumption by the formula of the density, because as it liquid is flowing, so it having its own density. So we are just making a simplest formula, making conversion here. So I have that rho is equal to that mean mass upon volume, and I can make the concept of the mass is there, that is called the density of liquid into volume of liquid. Volume, and the volume of the section here. So here I am just making the concept of that m is equal to density of the liquid, that is called the that mean rho is there. So we are just making the basic formula that how can we convert the mass into the part of a density, that mean area of the opening is there, with the concept of the velocity and all. Okay, so the volume can be stated in the two portions. Okay, so area into length which is covered by n liquid, okay, during the motion. So further I am just making the changing that rho into area is the a is there, and the length can be converted in the part in the part of, because we know the velocity is equal to displacement upon time. So I can make the conversion of the length in the sense of the velocity into time is there. So this is the one of the basic conversion I have made as the water is flowing through a section of a tube. So whenever I am just assuming the amount of the liquid at a section A which passing in a delta t time, so what is the kind of the mass we have? So here I can make the mass at A, that is called the m1, that is called rho 1 is the density of the liquid at a section A is there. Area of the cross section we have, that is called the A1 is there. Velocity, that is called the V1, and it is available in the delta t time. So this is the concept of the mass wave. This is called the equation number 2. Now mass at section B which passing in a delta t time, that is called the M2 is there. So it comes in the part of rho 2, as I am just assuming rho 2. A2 is the varying cross section, that means A2. V2 is the concern of the velocity, and delta t time which is the same for the liquid at the two places. Now if we are just assuming the concept of the equation of continuity, so we can assume the equation 1 is equal to 2, because the conservation of the mass is there. So the same amount that entering in a tube is equal to the same amount of the mass that mean which leaving the tube. So we can write here that rho 1 a1 v1 delta t is equal to rho 2 a2 v2 डेल्टा टी. ये डेल्टा टी से डेल्टा टी कैंसिल आउट कर दिया. और इनकम्प्रेसिबल लिक्विड की अगर हम कंडीशन डालते हैं, सो वी आर जस्ट इक्वेटिंग द रो 1 इज इक्वल टू रो 2 एंड इनकम्प्रेसिबल लिक्विड. अगर इस कंसेप्ट को हम फॉलो करते हैं, दैट मीन हम रो 1 बराबर रो 2 का एज्यूम करते हैं. सो वी आर जस्ट गेटिंग a1 v1 इज इक्वल टू a2 v2. इट सजेस्ट दैट v is equal to constant we have. A is the concern of the area and the v is the velocity we have. So here equation number 3 represent the equation of continuity. It state that during streamline flow of the non-viscous, definitely it's a term which is state that there is no kind of the fluid friction between the layers of a liquid. Non-viscous and incompressible fluid through a pipe varying cross sections and varying cross section, the product of velocity and area is constant. So here we can assume the basic concept that area and the velocity, the product of the area and the velocity is the constant for we have. So here we can that include the some following things regarding to the equation of that mean continuity, that mean equation of continuity shows area is inversely proportional to the velocity. Okay, or you can say the velocity is inversely proportional to the area. Okay, the area is inversely proportional to velocity. So we can ask the question that why the speed of water through a PVC pipe increases when we press outlet. Equation of continuity state that same amount of liquid passing through a varying cross section tube. Okay, so this is the that mean first topic we have equation of continuity. I'll just continue this one that another topic in the next lecture.